Welcome back, guys. This is Madhav PVL, and today we are going to discuss about circular queue. Yeah, so here we already have a queue, right? So we already have a queue data structure. Then what is the use of circular queue? You may also get a doubt like that. So let me just draw this array for the explanation. One, two, three, four, five. Yeah, the size is five, right? Size is five. So now I am just inserting the elements in this. Now I am just inserting the elements in this. So now if you just see this queue, so this is a basic queue which is satisfying this easeful function, right? So easeful function is nothing but if friend double equal to zero. So let us just give this indexes. So if friend double equal to zero and rear double equal to size minus one, so that is front is double equal to zero. So this is front and the rear is double equal to size minus one. That is 5 minus 1 is 4, right? So front double equal to 0 and size double and rear double equal to size minus 1. So this is satisfying a easeful condition. So according to the rules of the queue, this queue is full. So let us just consider this thing. So now I'm going to remove this 11 from here. So now, if we remove this, now front will get incremented. So front will be here, and accordingly, rear will also be in the same position. So basically, if this is happening, then but according to this easeful condition, front double equal to zero. So front will be in its zeroth position, right? Front will not change if we just delete an element. So front will be in its zeroth position and size will be and size minus rear will be size minus one. So nothing will change. It is full according to this. So the queue is full. So we can't just say that the queue is full, right? We have just deleted one element here, so this space is empty. We can just insert another element in the space, but according to the queue condition, this is full because it is satisfying this condition. But to overcome this, we are just inventing this circular queue. We are just implementing this circular queue. So the circular queue is nothing but it is just following a loop like this. So after the rear gets filled until its last position, then rear will reach its zeroth position after this last insertion of the element. So let us just write a step. Recursion step. So this is a recursion step. So rear is equal to rear plus 1 percentage size. So this is a step which plays a crucial role in this life of a circular queue. So in the circular queue, rear is equal to rear plus 1 percentage size, right? So rear is equal to 4 plus 1, that is 5. So 5 percentage 5 is a 0. So it will reach its 0th position. So 0 plus 1 is 1. 1 percentage 5 is 1, right? So it will reach its 1 position. So it will reach to 1 and then 0 and then 2 and then 3 and then 4, and from 4 finally it will reach to its 0th position only with the help of this recursion loop. So rear is equal to rear plus 1 percentage size. So only this thing is used to just perform this operation in this circular queue. So this plays a crucial role. So let us just get into the code. So now I am declaring this public class circular queue and then declaring its size as 5, and then declaring front and rear, and this array I am declaring the size as 5. So in this circular queue I am just declaring fixing this values as front equal to -1 and rear equal to -1. So now I am just checking this easeful condition. we can just check this easeful condition with another one, that is if front double equal to rear into rear plus 1 percentage size. We can also check with this condition. So if this condition satisfies, we can just return true. Otherwise, we can just use this q function also. So front double equal to 0 and rear double equal to size minus 1. So we need to just get into this loop, and then front double equal to rear plus 1. If front is double equal to rear plus 1, then also we can just say like it is full, but it is not satisfying all the condition. So this will be efficient. So let us just remove this whole thing. This will be efficient according to this circular Q condition. So now we are returning true, and then we are returning false if it is not full. If front double equal to rear plus 1, rear into rear plus 1 percentage size. So here we are, sorry, it's not rear into rear plus 1. It is just rear plus 1 percentage size. So now Boolean is empty. If front double equal to minus 1, written true. So if front is double equal to minus 1, then the recursion of the rear doesn't happen, right? So if front double equal to minus 1, then automatically rear will be in its minus 1 position, right? So the recursion doesn't happen, then that is empty condition. So it will just return true, and else it will return false. So NQ. Now, if it is full, then it will just pass a command like Q is full. Otherwise, if front double equal to rear, then we will just initialize the value of front is equal to 0. That is, it will be in its 0th position. So F will be in this 0th position, and then now front equal to 0 and rear is equal to rear plus 1 percentage size, and rear also will be in its minus 1. So now rear will be in its minus 1 position, rear plus 1 percentage size. So rear plus 1 is nothing but 0 percentage pi, that is 0. So rear will be in this position. So the element will be inserted in this rear condition, right? So the element will be inserted in this rear. So let us just make it as an empty. So this will be front and this will be rear. So now the element will be inserted in this rear position. Now next again, if you want to insert another element, so again NQ, it is not full, right? So it's not full. So it is just thinking of front double equal to minus 1. So front not equal to minus 1, right? So front will be in its 0th position. Rear is equal to rear plus 1. So rear is 0. So 0 plus 1 percentage 5, that is 1 percentage 5, that is 1. So rear will just move up front towards front, that is to first position. And then now the element will be inserted here. So in this way, the NQ operation will work on, and then DQ will check for is empty. And if it is empty, then it will just pass a command like Q is empty, else the element is equal to item dot front. So the element which is at front will be removed first. And then if front double equal to rear, the front double equal to rear is just nothing but it is just containing only a single element. A single element is nothing but if front is just in the position of 0 or 1 or 2 or 3 or 4 and rear is also in its same position, then we can just say like it is just containing only one element. Here I just mentioned it very clearly. So we can just reset the queue by just deleting that one element. Else front equal to front plus 1 percentage size. Now front will be just incremented. So front equal to front plus 1. After deleting this value 10, the front will just move a little bit front. So now here it is containing only single element where the front and rear in its one single position. So now it will just delete that one element, and then this is about DQ. So it will just delete the DQ like this. So now let us just see this display method. So display method is nothing but it is just checking for the Z is empty. So if Q is empty, then we don't need to display any elements, right? So it is just checking for that, and for else we are just passing the command like items. This is just for representation purpose. And now we are writing this for loop like from I is equal to friend. So let us just bring back this. So from front, I is equal to front, and then I not equal to rear, and I is equal to I plus 1 percentage size. So I will just recurse from this position to this position, and from this and from this and then this. And finally, it will again reach to its initial state. So for that reason, we are just writing that recursion loop here, and then we are just displaying the elements from front with the help of these items at I. So items at I is nothing but from 0, 1, 2, 3, 4. We are representing that, and we are just printing out like that. And this is a main function. So like this, we are just declaring a scanner element and boolean b is equal to true. And now we are just using this while loop that is true. And then now we are just declaring this menu like enq, dq, display exit, and we need to just enter our choice. And for inserting the element, we need to just scan an element, and for deleting, we don't need to scan anything. And for display, we will just use this display function. And if we just make the b is equal to false, then it will just come out of this recursive function that is while, and the loop will just get completed. So this is about circular queue. Thank you for listening.